Bismillahirrahmanirrahim. Hello everyone. I hope you are all doing well. I am Azmat Ali and I welcome you all in class of O-level mathematics. Our discussion is continue on linear inequalities in two variables. In today's lecture, from this chapter, we will discuss a very important topic that is related to the how to find the least and the greatest value of an linear expression ax plus by from the graph of linear inequalities in two variables. Here I am using new Syllabus Mathematics series, Syllabus D for 7th edition by Dr. Joseph Yeo and consultant Dr. Yeap Ban-Har. Related to the topic, in this book there are there are 3 questions available in exercise 1A, and there is a one problem that is a practice now 3 and work example 3. These 5 questions or 5 problems are related to today problem. In today's lecture we will discuss about question number 4. Its statement is leave unshaded the region defined by the following inequalities. These are the 4 inequalities and we need to find a region which we have to leave unshaded, and from this graph we need to find the greatest value which satisfy the above inequality, greatest value 4x plus y. So this is very important question regarding your exam. Okay, to solve this question we will follow the following steps. I have written as an unshaded region is our required region. So to solve the problem, we will follow the following steps. Step 1. Find the opposite inequalities and their associated equations to the given inequality. So here we have these 4 inequalities. So firstly we find what are the opposite inequalities. The opposite inequality to x greater than or equal to 0 is simply x less than 0, and its associated or associated equation or boundary line is simply x is equal to 0. That can be obtained by just replacing a less than sign with equal sign. The second one opposite inequality to y greater than or equal to 0 is simply y less than 0. Its associated equation is simply y equal to 0. 3x plus 4y less than or equal to 24 has opposite inequality greater than 24, and its boundary line is 3x plus 4y is equal to 24. The last one is 2x plus y greater than 8, and its boundary line or associated equation will be simple an equation 2x plus y is equal to 8. This is our first step. What is the second step? Shade the region followed by the opposite inequality. Now we will shade the region that is followed by these opposite inequalities. So firstly we draw x-axis and y-axis here. So this is origin, this is my y-axis, and this is my x-axis here. Now x is equal to 0. X is equal to 0 is actually represent y-axis. So we need to shade the region x less than 0. X less than 0 mean left of y-axis, or left of x is equal to 0. Left of x is equal to 0 mean left of y-axis. So the graph followed by the inequality x less than 0 is simply left of y-axis. This represent the graph of x less than 0. This graph lies in uh, this will lies in second and third quadrant. Next one is y less than 0. Y less than 0 mean the graph below the x-axis, because y less than 0, the boundary line or associated equation of y less than 0 is y is equal to 0. What does y is equal to 0 represent? Y is equal to 0 represent just x-axis. So y less than 0 mean below x-axis. So now your graph lies below x-axis. Below x-axis mean graph lies in this region, that is fourth quadrant and third quadrant. So this region represent y less than 0. Next one. The next two inequalities consist on two variables x and y both. So for this we will convert this equation into two intercept form. What is the two intercept form of this? 3x plus 4y is equal to 24. We convert it into two intercept form. How can we find its two intercept form? By just dividing this on both sides by 24. We have 3x by 24, 4y over 24 is equal to 1. This will become x by 8, y by 6 is equal to 1. This is called two intercept form. What is called? Two intercept form. The number in the denominator of x is equal to 8 represent this line will cut the x-axis at x is equal to 8, while the number in the denominator of y that is 6 here. This shows that this line will cut the y-axis at at y is equal to 6. Suppose suppose this is equal to this is 1 unit, 2, 3, 4, 5, 6. So this height represent y is equal to 6 here, and similarly this is x is equal to 1, 2, 3, 4, 5, 6, 7, 8. Suppose this distance represent x is equal to 8 here. So by joining these two intercepts, we can draw the graph of this line. So this solid line represent the graph of 3x plus 4y is equal to 24, but we need to find the graph of this inequality. As this inequality has a greater than sign, so the shaded region will above this line. So your shaded region will lies above this line like this. So this shows, this yellow line shows the shaded region, followed by the inequality 3x plus 4y greater than 24. The last one inequality also consists on two variable x and y both. So firstly we convert this line into two intercept form. By dividing on both sides by 8, we have x by 4 after cancellation, and this is y by 8 is equal to 1. X by 4 represent the graph of this line will cut the x-axis at x is equal to 4 and y-axis at 8. So suppose so this is y is equal to 6, this is y is equal to 7, or suppose this is y is equal to 8. This height is y is equal to 8 here, and the x-intercept in this case is x is equal to 4 here. X is equal to 4, 1, 2, 3, 4. This is x is equal to 4. Now by joining these two intercept again, we can draw the graph of the last inequality like this. This one. This one shows this solid line. This solid line shows the graph of 2x plus y is equal to 8. 2x plus y is equal to 8. Again, as this inequality has a greater than sign, so the graph will be above this line, like this. This green lines shows the graph of 2x plus y greater than 8. Now the unshaded region lies in this area, this one. This is a quadrilateral. This shows the unshaded region, our unshaded region. That can be seen more clearly in the following graph. You can see this picture more clearly here. This is your required region. This is your unshaded region. This is your unshaded white region. This white region shows your unshaded region, and this is our required region. Next, the next step, as we need to find the greatest value of 4x plus y. So the third step that we will use here. Next, we find the vertices of the unshaded region. You can see this unshaded region is actually a quadrilateral whose first vertex is origin. So the first vertex is origin here. This is origin whose coordinates are 0, 0. The next vertex is this point, and you can see this point is x is equal to 4, y is equal to 0. This is 1 unit, 2, 3, 4. So let's say this vertex is A, whose coordinates are 4, 0. The next vertex, this is B, and this we will calculate this point B. And the last one, suppose this is point C, whose coordinates are this height is 6. This is 1 unit, 5 to 1, 6. So the coordinates of C are here. C, x0, y6 here. Now, how we will find the coordinates of B here? This is our target. If you notice, the vertex B is in the point of intersection of the two lines, this and this line. Now, one of the line, this line that cut the x-axis at 4, 0 was this 2x plus y is equal to 8 here. So one of the line is 2x plus y is equal to 8. 2x plus y is equal to 8, and this line that cut the x-axis at point 8, this line was, which is given by 3x plus 4y is equal to 24. 3x plus 4y is equal to 24. So firstly we solve these two equations simultaneously and find the point of intersection, that is a B here. How we can solve these two lines? From this line we find value of y, which is 8 minus 2x. We substitute this y is equal to 8 minus 2x in this equation. We have 3x plus 4 into 8 minus 2x is equal to 24 here. This will become 3x plus 32 minus 8x is equal to 24 here. Yeah, 3x minus 8x, this is equal to minus 5x, this is equal to minus 8, x is equal to 8 by 5. Substituting this x is equal to 8 by 5 in this y, your y is equal to 8 minus 2 into 8 by 5. This will become 40 minus 16. 40 minus 16. This is 24 by 5 here. Yes. So the coordinates of B are here 8 by 5 and 24 by 5. 8 by 5. Coordinates of B are 8 by 5 and 24 by 5. The last step. Evaluate the greatest and the least value of 4x plus y at the vertices and find out the required value. Mean to say, here we write vertices. The first vertex is origin 0, 0. The second vertex is 4, 0. The third vertex is 8 by 5 and 24 by 5. And the last one is C 0, 6. And here we find the value of 4x plus y. Suppose this is equal to some number p. So firstly we put this point origin in this expression we have, this is equal to 0. Now we put coordinates of A, x is equal to 4, y is equal to 0, this is equal to 16. The last one we put x is equal to 8 by 5, y is equal to 24 by 5. This is equal to 32 plus 24, this is 56 by 5. This is approximately 11.1. 11 point something, you can calculate, this will be 11 point something. Last one is 4 into 0 plus 6, this is equal to 6. Now we need to find the greatest and the least value here. What is the least value? This least value is 0. This is the least value at coordinate origin. And what is the greatest value? Greatest value is 16 at coordinate at vertex A. So this is the method to find the greatest and the least value of the linear expression that satisfy the given inequalities from the graph. So the greatest value of 4x plus 3y lies at this coordinate, at this point here. So I hope today lecture is helpful for you. If you find my videos helpful, kindly like and share. Inshallah, we will discuss a very interesting topic that is actually the words problem related to linear inequalities in the next lecture. So see you in the next lecture. Take care. Allah Hafiz.